Good morning, everyone, or good afternoon, depending on where you are in the world. Thank you for joining us today, and welcome to today's webinar. This is the sixth and actually the last webinar of the 5G MOBIX's webinar series on results and lessons learned on 5G for CAM from the project's different trial sites in Europe and beyond. So far, we have looked into the trial sites of Finland, France, Germany, the Netherlands, and South Korea. And today we have the opportunity to get an insight into the Chinese trial site. My name is Sevi Christoforou. I am a Communication and Dissemination Officer with ICCS, which is the Institute of Communication and Computer Systems in Athens. And I'm also the Dissemination Task Leader for 5G MOBIX. I will be moderating the webinar today. So before we get started, I would like to inform you that throughout the presentations, you will have the opportunity to submit your questions to the question box that you can see on your control panel. We will collect them and take them all at one time towards the end, where we will dedicate 15 to 20 minutes for a Q&A session. Now, if you're experiencing any technical issues with the audio or not seeing the presentations properly, for example, feel free to use the chat box that you can also find on your control panel to notify the organizers. Now, for introducing the agenda and today's speakers, I would like to, I see most of you have your webcams open, but all of you to turn on your cameras. Thank you for being here, and a warm welcome to all. So I'll start with the introduction. Our first speaker for today is Yanjun Shi. Dr. Shi is an associate professor at the Dalian University of Technology in China and a researcher at the National Collaborative Innovation Center for Project 2011 in DUT. He received his PhD degree in 2005 in computer engineering from DUT and has worked on collaborative intelligent systems and connected vehicles for more than 15 years. He has published more than 30 papers in scientific journals and international conferences and workshops. He has served as an associate editor and guest editor for several journals and has also been a program chair for more than 5 international conferences and workshops. He's working on the 5G MOBIX project and other 5G V2X projects in China now. Today, he will introduce us to the 5G MOBIX project and also the work that has been done. Now, our next speaker is Yanqiang Li. He is the deputy director, researcher, and master tutor of the Automation Institute of Shandong Academy of Science. He's the deputy director of Shandong Key Laboratory of Automotive Electronics Technology, and he's also a member of the Shandong Artificial Intelligence Technology Standard Committee. In recent years, he has presided more than 20 national cooperation projects, major scientific and technological innovation projects in the Shandong province, and also has been involved in a special project for the Shandong Israel International Scientific and Technological Cooperation. Moreover, he has published more than 20 high-level papers, authorized 34 patents, and won 2 third prizes for scientific and technological progress in the Shandong province. Today, he will take us through the 5G MOBIX Chinese trial site. Welcome. Our third speaker for today, and the lady of the company, is Jing Ma. Dr. Ma is currently a postdoctoral research fellow with the Institute of Automation in the Shandong Academy of Science in China. She has received her PhD from Auckland University of Technology, New Zealand in 2019, and her expertise includes multi-agent systems, distributed control, and automated vehicle testing. Dr. Ma will show us a video explaining the recent trials and different user story demonstration of the Chinese trial site. And now, last but certainly not least, we have Yanjun Li with us today. Yanqiang is a PhD candidate at the Dalian University of Technology, working in the automated driving and cloud edge coordination research. He has received his bachelor's degree in mechanical engineering from DUT in 2020, and his research interests include 5G applications, Internet of Vehicles, and intelligent traffic. Since 2020, he has been working on the 5G MOBIX project, leading the user stories definition task at the Chinese trial site, and also working in the remote driving use case, specifically focusing on vehicle development and execution of trials regarding 5G network. Yanqiang will present the trial results and also the lessons learned from the Chinese trial site. Again, thank you all for being here with us today, and I'm looking forward to seeing your presentations. I'm not taking any more of your time now. So, Yanjun, the floor is yours. And make Yanjun the presenter, correct? Super. We
Okay.
can see.
Can you hear me?
We can hear you and we can see your screen.
Okay. Hi, sorry. Thank you for introducing me. Hello, everyone. I'm Yanjun Shi. I come from Dalian University of Technology. Thank you for your attention. Firstly, I will thank the article and the other Wuji 5G MOBIX partner for the great cooperation and the support. Here, I will make the general introduction to 5G MOBIX China trial site. Firstly, please allow me to introduce the 5G MOBIX project. This project is an EU-funded innovation action. There are 50 partners from 11 countries in Europe and 10 non-EU funded partners from China and South Korea. We have two main objectives. The first one is to accelerate development of 5G and cross-border areas, such as carry out trusted along export corridor to access 5G capability for CAM, to qualify the 5G infrastructure and evaluate the benefits of 5G within the CAM context, and to identify spectrum allocation gap and contribute to standardization and 5G CEF preparation. Another objective is to define development scenario recommendation, including as border context, such as to perform cost benefit analysis and impact assessment, to identify new business opportunities for 5G-enabled CIM, and to investigate legal, regulatory, and security issues. Okay, now is the 5G MOBIX rollout at a glance. As you may know, we have two cross-border products, 4 EU trial sites and 2 Asia trial sites. Regarding network, we have 8 NSA 5G network and 4 SA. Also, we have 29 GMB. Regarding vehicle and roadside infrastructure, we have 24 L3 plus with automatic vehicle and 30 5G-enabled OBU. Also, we have 22 ICU and MAX. Regarding use case, we have 5 use case categories focusing as border operation. Also, we have 24 unique use story Regarding China trail side, we have advanced driving, vehicle platooning, and remote driving use cases. 5G MOBIX mainly handle the cross-border issue. We identified 11 SDIAs and 26 secretarial solutions. Each side will connect as SDI and test the 5G solution. The China trail side handled SDI 4 and SDI 5. Also, we developed CS4, CS5, CS13, and CS14. About our key stakeholders, we have 6 full partners and 4 associate partners, including China Mobile and China Unicom. Also, we have 40 China members. We have an advisor, expert, where we have 4 TriStar leaders and the other members. As you can see, our work with a lot of partners. Thank you.
Thank you, Yanjun. Now I'll give the floor to Yanqiang.
Okay, can you hear me?
We can hear you.
Okay, wait a moment. Okay, let me see. Can you see my screen?
Yes, we can see your screen.
Okay.
If you put it on, yeah, super.
Okay.
Yes.
Okay. Good morning, everyone. In the following, I'm going to give you with a brief overview on the China trail site. Okay. I'm Yanqiang from Shandong Academy of Science, located in Jinan. Okay. I'm going to wait a moment. I'm going to start my presentation with following 6 parts. First is an outline for China trail site with description of test deployment and infrastructure integration. Then I will state challenges in China trail sites and consider solution for connected and automated mobility. After that, I will review 3 user stories and specific user case shared in China. Finally, I will come to the China contribution to both cross-border corridors, Spain, Portugal, and Greece, Turkey. The trail in China trail sites were mainly completed by 4 partners. China trail site is mainly located in the enclosed section of the eastern area of Shandong Academy of Science, named Jinan 1, shortly SDS, and the section of Shandong Binlai Highway, named Jinan 2, SDHS, contains an intelligent network highway test base covering both urban roads and highways. According to the 5G MOBIX project's objective, the China Trail site simulates the problem-solving of 5G cross-border issue in the Jinan site. So we deployed a dedicated 5G SA network with China Mobile and two commercial networks, China Mobile and China Unicorn. One roadside unit and two MECs were deployed for specific use case. We have developed and tested the data transmission application for servers, edge, and vehicles. Two vehicles as automated vehicle with level 4 and two connected trucks with level 2 for the following user stories. This simulation designed 3 user stories to verify the service performance of CM application with 5G features, including route driving with data ownership focus, use case 4.4, cloud assisted advanced driving, use case 4.1.4, and cloud assisted platooning use case 2.3. Before moving on the specific CAM user stories, we will first go over the challenges faced over the 5G network at the China Trail site. The first challenge is how to simulate and solve the low network coverage problem encountered by vehicles passing cross-border section on a test site. The second challenge is how to solve the problem of session server continuity caused by public operator network switching. In order to tackle this technical issue, we deployed a dedicated 5G shared
I think I don't know if it's just me, but I think we lost I'm sorry to interrupt you, Yanqiang, but I think we've lost the sound. Oh, we lost you completely. We cannot hear you, or
Hello?
I can see that now we can hear you. You're back.
Okay.
Sorry. Go ahead,
Okay.
please.
Okay. For the first story, we will okay. For the first story, for the first user story, we will present a remote driving with data ownership focus, shortly RDDO. The RDDO is to utilize new 5G feature to remotely control vehicle across virtual hardware area with low latency and continuous V2X service. The related export issues are low coverage area and session and service continuity. The 5G specific enabler used in the US, such as MEC, multi-access edge computing for low latency communication, and MQTT broker for persistence and integrity of data. For use case 4.3, we have two deployed MECs over to commercial mobile network operator, China Mobile and China Unicorn. The remote control center connected to MECs via public internet. Vehicle 1 subscriber IEDO service deployed at the MEC or MQTT client from the beginning of the route over the bad RF area with 4G link. Vehicle send basic safety message BSM to ROC using MNO1 over MQTT protocol. In turn, the ROC sends the command flow to the vehicle via TCP protocol. The remote driving driver controls the test vehicle moving to the route RF area with a switching link to 5G connection. When the testing vehicle comes to a location for virtual network handover, the trick event embedded in OBU will occur for the switching of MNO1 to MNO2. Then the new sessions for remote driving service will be established in area 2. In our use case from remote driving, the first step is to establishing a connection between the testing vehicle and the ROC. When the 5G coverage whole or bad RF condition, low coverage area appear in this phase, multimodal multi-SIM as a considered solution was adopted. The data sent from the vehicle to MEC1 server was stored for the traceability of data ownership. When the vehicle moved to the handover area, the dominant cross-board issue is session and service continuity as the switching event occurred between MNO1 and MNO2. The use case adopted multiple multi-modem multi-SIM solution to maintain the dual TCP session simultaneously and the double MQTT client to provide redundancy of MQTT session in the case data produced at a handover area briefly is owned by 2 MEC. After that, the vehicle moved to the area serviced by MNO2. Affected vehicle connected to MEC of MNO2. For the second user story, we will present a cloud assisted advanced driving, shortly CAAD. The CAAD is to utilize 5G to exchange message with low latency to cross the intersection. The related export issue are low coverage area and session service continuity. The 5G specific enable used in the US, such as MEC for low latency communication and MQTT broker for exchange of information between different domains. For use case 1.4, due to the same trio sites as remote driving, MECs were deployed over 2 commercial mobile network operated China Mobile and China Unicom. Vehicle 1 subscribe ADCA server deployed at the MEC over MQTT. Well,
sorry to interrupt you again. We lost the last minute.
Okay, maybe
we can hear you again.
Okay.
If you can turn off your camera, perhaps to facilitate the network connection.
Okay, let me close my camera. Okay. Okay, let's continue. The vehicle sent basic safety message to ROC using MNO1 over MQTT protocol. When vehicle 1 come to a location for virtual network handover, the trigger event embedded in OBU will occur for the switching of MNO1 to MNO2. Brooks 1 shares vehicles 1's information to Brook 2 for the coming coordinated collision avoidance in area 2 section vehicles approaching the intersection. A potential collision point related to a vehicle with orthogonal driving directions is shown in this figure. In our use case for advanced driving, the first step is establishing a connection between the testing vehicle and the closed MEC. With the 5G coverage whole or bad RF condition, the coverage area appear in this phase. Multiple modem multi-SIM as a considered solution was adapted. In Genantria site, the interconnection of MECs were realized within software-defined network via Internet. Okay. For the third user story tested in China test site is cloud assisted platooning, shortly CAPT. The CAPT is to utilize 5G to exchange messages with low latency to cross virtual border.
Yanqiang, I think we lost sound again. We cannot hear you. No, I can see that you're speaking, but unfortunately we cannot hear you. Could you try? Yes?
Sorry. Okay, let's continue.
Yes, perfect.
The leader and the leader and the follower send a basic safety message to connected MEC use MNO1 or MQTT protocol. The following vehicle also have a certain perception and planning decision making ability. In our use case for platooning, the first step is also establishing a connection between the testing vehicle and the closest MEC. with 5G coverage hall and bed condition. Low coverage area appear in this phase. The platooning send basic safety message to MEC via MQTT UU. Data were visualized as a UA platform deployed at the cloud server. When the platooning moved to the handover area, the leading vehicle trigger and the switching event occurred between MNO1 and MNO2 with brief service interruption. The use case adopt a modern multi-SIM solution to maintain dual TCP session simultaneously and double MQTT client to provide redundancy of MQTT session. After that, the platooning moved to area 2, serviced by MNO2, affected the vehicle connected to MEC of MNO2. CAPT session is recovered, send bit SM to the connected MEC due to data being synchronized between two MECs. Inter-MEC data were exchanged between MEC1 and MEC2. The interconnection of MECs were realized with in software-defined network via Internet. As for the China contribution to cross-border corridors, our local group work together with other 5G MOBIX partners to contribute to the deliverable of WP2 to WP6, aiming at the requirement of 5G technology cross-border problems. We are committed to solving two technical issues as complementary specific trio and cross-border section XBI4 low network coverage area, XBI5 session service continuity. 3 user stories trio in China test sites with the dedicated 5G SA network as a complementary focus on specific issues which are contributing to the CBC trial evaluation site. To the conclusions, this presentation introduced the 3 user stories in China test site. Is negatively challenge and considered solution. The next presentation, Dr. Ma Jing will show a demo video about the user stories. Thank you.
Thank you so much, Yanqiang, for this presentation.
Okay, thank you.
Yes, let's move on. To the video. Let me see. One second, and Jing Ma, you can, once I started, the floor is yours.
Okay, now I'm going to show you the video, and according to these 3 user stories. Well, the first page is our 4 partners. And well, that is the overview for the China trial site. And that is left side is the closed site. And well, still according to those 3 user stories. First one, because we actually make I don't want to mute it. I just want to, okay, that's a video. I just show something. So please don't mute me. Yeah, here is, we have chose China Mobile Data Center and China Unicom Data Center. And that is a closed track testing. Well, that is our test vehicle. The GPS, camera, and LiDAR have been installed in this test vehicle. And you guys can see this one. And also, OBUs is set up in this car as well. Well, here we can see this 5G deployment. And there are multiple features that can support NSA and integrations of active RF and passive. Well, that is that arrow, that blue arrow, can say that is a remote driving track. Well, actually, this road is very wide because we took this video. It's very high, and also the trees and block some sites. So actually, in real, this road is very wide. Okay, first user case, user story, remote driving. The remote driver in the right side, he's in front of the screen. He controls the test vehicle moving towards this road. And that is handover point that from 4G to 5G. And this vehicle move forward with a constant speed. Yeah, we recorded this video to show how stable or this vehicle operates. So we highlighted this point, handover point, China Mobile to China Unicom. That is two operators. That is a handover point. But we can see that it's very smooth when we change this provider. The second user story is cloud-assisted advanced driving. It will cross the intersection, and we use the same test vehicle. And in the video, we can see there is an RSU deployed in the intersection. The RSU is set up just cross right in the intersection. In this user story, we are going to show two vehicles are approaching to the intersection. And yeah, we say that it's the vehicle turned left because when they approach to this intersection, the RSU, according to the traffic strategy, the RSU sends the comments or message to both cars. And this one says to avoid collision. When the front car turn right out to the main road and the testing car just going forward, straight forward, so they still follow the traffic rules. And this way is quite interesting. We have a pedestrians here. So when the test vehicle bump into with a real person or the pedestrian, he stopped for a while, wait the pedestrian cross the road and then going forward. The third use case is cloud-assisted platooning. Well, in this case, we use the two trucks. And also we test the low latency areas. So that is one of the test vehicle. And also we have OBU deployed in the truck to support 5G, well, as well as 4G. G is installed in this traffic site, and in this area, I mean. And this map shows the test route for the cloud-assisted platooning. The point is a circle, and these two circles are handover point. Well, at the start of the test route, the leading vehicle sends the message to the cloud. Well, would you like to apply to the formation creation, or that to send it to the cloud? And the following vehicle will receive the message and then send, okay, I'm going to join the formation message to the cloud. We also created our user interface. Well, this is all about our video, and thanks for taking time to watch this video. And I think Jiajian will take over for the last part.
Thank you so much, Jing. Thank you for taking us through the video. Yanqiang, the floor is yours.
Jiajian.
Hello everyone. Good morning and good afternoon. Okay. In the following presentation, I'm going to provide you with the trial sites from China trial site. This presentation follows 5 parts. Firstly, I will introduce the considered solution that Chinese use cases adopted: dual modem, dual SIM solution. Then, it's an outline of measurements and the results. After that, we will review scenario-agnostic test case results. Finally, we come to the scenario-specific test case results focused on remote driving. As Yanjun Shi said, China handled 2 cross-border issues with 4 considered solutions. Here, we focus on dual modem and dual SIM solution. When the vehicle shuttles through very low coverage areas because of sparse populations at the border, areas of low or no coverage may appear close to the border, threatening the CAM application service continuity. A change of mobile network operator in a roaming situation causes continuity issues or suboptimal latencies between each backdoning. Due to the single site shared by multiple operators in China, it is difficult to find a real boundary divided by different operators. So we used 2 modes serving over 2 different areas to simulate a cross-border scenario. When the vehicle arrives at the specific location, the network switches from one mode to another. At a specific location, perform a handover to another mode as the outcome of the decision-making component of a network redundancy function that exploits MAC service. The considered solution, marked as CS5, to utilize multiple modes has been developed based on dual models and dual SIM connections. Over the adopted solution, we used 2 5G modes, China Mobile and China Unicode, for testing user cases. A virtual border at 5G low coverage to simulate a cross-border scenario. Each modem has its own MQTT application client associated using the respective mobile network. When preset location X is reached by the vehicle, the application establishes a new session via another modem's MQTT client. To realize connection redundancies with 2 MQTT clients, we use an onboard unit integrated with 5G modem by China Mobile SIM card. Another 5G modem uses China Unicode SIM card. Before moving on the specific CAM scenario tests, we will first go over some scenario-agnostic tests over the 5G networks at the CN trial site. This gives us a general understanding of the environment and the kernel conditions, and sets a baseline for the actual CAM tests. In general, 5G NSA in commercially used networks modes performance results are specific to the cells at our site. Different service requirements have different emphases on network requirements. in order to provide a stable and efficient network for use cases, independent operation and maintenance. The dedicated 5G SA network we used can set up independent subnetworks to support several scenarios of 5G applications. We see the China Mobile Mac user equipment throughput here. China Mobile involves Mac developed at gateway of Jinan node, Shandong Mobile Data Center. We measured downlink and uplink throughput characterize the supporting ability of transmission workload for V2X messages between Mac and user equipment. Throughput results are for TCP traffic, quite sufficient capacity in general for our purpose and the use cases. In our use cases, we heavily rely on the messages uploading instance and their interconnection. So, as a part of agnostic tests, we also investigated the round-trip time between China Mobile Mac and the vehicle. We are not using in our actual deployment use case tests, but just as a stationary test for baseline. The values shows a good round-trip time around 10 to 15 milliseconds. In our use cases for remote driving, we investigate two traffic flow. Remote driving service deployed in the remote control center pass the basic safety message and shows the speed of vehicle location information act. Vehicle running on the route continually upload BSM via UU interface and MQTT protocol. The driver at a remote control center sends commands to maintain the vehicle running, including acceleration, deceleration, and steering. As for our testing configuration, we use single SIM cases as test baseline and the dual mode aggregation for the considered trail. We first look at the user data rates resulting from the BSM flow. In the BSM flow of a UU interface, results of data rate in the link aggregation mode are more concentrated than those in the single link mode. The small variance in data points, especially in the link aggregation case, also confirm the available capacity in the networks. The average data rate of the user plan in the link aggregation mode is higher than that in the single link mode. Link aggregation mode achieves more efficient utilization of the kernel without much perceivable quantities degradation. Let's move to the next part. We observed the latency in MQTT messages, which is used for vehicle information in cloud assist platform. We look at the uplink direction. The mean values from link aggregation are at quite acceptable levels, around 30 to 35 milliseconds. The similar variance in the data points than other two configurations. However, there is a large variance in China Mobile that reveals the performance were affected by unstable public networks. Some outliers even go up to the large diversion from the mean point. In general, compared with the other two single link modes, the link aggregation mode has smaller delay jitter, and its average delay is also better. As a last set of results in this section, we observe the data rate in command messaging, which is used for vehicle controlling from remote center. Much higher data rate values compared to BSM flow, and also large variance in the command flow over UU interface. The data rate of the downlink comment stream has a large fluctuation range. The average data rate of the user plan in the link aggregation mode is higher than that in a single link mode. To the conclusion, due to the remote driving results have been obtained in a hybrid network deployment of V2X applications, like broker applications, highly dynamic conditions while conducting driving trials in a public network, especially when a single SIM card over China Mobile is used in the measurement of uplink end-to-end latency, a worse performance than dual connections. We see the link aggregation mode provide the best performance compared to single SIM trials. Aggregation mode supports the synchronization of back video and the operation instructions as much as possible, improve the accuracy of control, and avoid misoperation or accidents. Future hybrid V2X applications will benefit from integration of 5G SA networks compared with 5G NSA. SA architecture has shorter air interface latency and large uplink bandwidth, which can better meet the network requirements for remote driving. With the subsequent deployment and application of MAC, the delay can be further shortened. Let's go to the next section about lessons learned on 5G for CAM in channel trail site. The lesson we learned first is the benefits with dedicated 5G SA network. In channel trail site, remote driving trails have noted the benefits of deployment of the dedicated 5G SA network for CAM application as ensuring the security and ownership traceability of data. Also, the dedicated network is autonomous and controllable. The end-to-end components were self-established and completely isolated from the public network. The performance for dedicated network will not be affected by network congestion that occurs in public network. Another lesson we learned is about dual modem, dual SIM as a considered solution. Channel trail site utilized a dual modem, dual SIM solution to simulate and solve the problems of service continuity in a cross-border scenario. The dual community model solution provides two connections at the same time, which provides link redundancies for operators during the switching process, reduced server interruption time, and improves the service continuity of CAM applications. That's all my presentation. Thank you.
Thank you so much, Yanqiang. Let me share my screen. Well, thank you all for your insights and presentations. That's been very, very insightful. We're now opening the floor for the discussion. I would like all the speakers to, we'll ask them to turn on their cameras again, so we can move on to the Q&A session. Everyone, please feel free to type your questions to the question box. You can also indicate the speaker of the presentation you are directing the question to. Now I can already see we have questions. Give me 1 second. All right. So with remote driving, what speed do you think can be achieved? Is that related to the network characteristics And what are the main influences on the maximum speed?
You mean remote driving?
Yes, the use case.
The use case. You mean what's the most important for the network state quality, or yeah, I didn't get you.
All right, let me repeat the question.
Yeah, please repeat the question.
Of course, of course. What speed do you think can be achieved? Is that, yeah, and if that is related to the network characteristics?
Jiajian, yeah, I have to ask Jiajian to answer this question. So what speed can we achieve for this? And
about 25 to 30 kilometer per hour.
Okay. Yeah.
When we carry out our trials, yeah, as shown in the demo video.
Okay. Yeah. Oh yeah, I can see the message chat. Okay. 25 to 35 kilometers per hour, and is that related to network characteristics? What are the main influence of the maximum speed? Well, I think there's that still depends on the network characteristics.
And about the influence with the speed, because the RF condition is different over the whole test room. Yeah. So when speed up our vehicle, the fluctuation may appears in the trail, and some delay may up to about 50 million seconds. I remember. So I think the speed is affect the network performance. Actually, anyway, in our trail site, the test road is in a closed in the Jinan, and the Shandong academic science. So the velocity is not too high. Yes. Okay. Very much.
Right. Thank you, Yanjun. Is there anything else you would like to add, perhaps, Jing? No?
No, I don't have questions. Yeah.
All right. Let's move on then to the next question. I will also type it so you can see it, but let me also ask it. For the user data rate comparison box plot with single scene and link aggregation, I would expect the aggregated one to be the combination of both single bandwidths. Why are they practically the same?
Why would we choose? Yeah, that's a good question for the user data rate comparison with single SIM card and link aggregation. One to be the combination of both single bandwidths. Why are they practically the same? As the software, well, yeah.
Yeah, I got
to ask Jiajian to answer this question.
Because the trial we carried out is performed by the public network. through output is affected by the public network performance, such as China Mobile and China Unicom. And why the same is maybe have some software certainly, but the main problem is the hardware interface about the USB. It is the maximum throughput is 10 Mbps. So we think in the later trials, we are going to use a large throughput the interface to carry the trips. Okay, thank you.
Thank you, Yanjun. Another question. What is the contribution of the 3 user story trials that were carried out in China to the cross-border corridor trials in Europe?
Yeah. Okay. I think I can answer this question because, yeah, according to the 5G MOBIX Z objective and the China trial site designed this and try to simulate the problem solving of the cross-border issues in the China site. So our idea were to, explore multiple 5G MNOs, such as China Mobile and China Unicom from the different providers to simulate the related scenarios. So we deployed the multiple 5G network in the closed trial and of the Shandong Academy of Science. So I think that is what the main stories why we designed these ones. And also we have autonomous vehicles ready, so which is a good example to test the 5G connections.
Thank you so much, Jing, for your answer. Perhaps another question for the remote driving use story. Does the actual network switching cause any service interruption? And if so, how could this be solved?
Well, yeah, the actual network switching cause service interruption, of course, but we have the 2 service on board. So when we switch the network, so the driver or all the service is seamlessly. So you cannot actually observe it. We were trying to discover the specific time about the switching time, but that will be our next topic, next research. But at the moment, that is seamlessly to change the network handover, to cross the handover point.
All right. Perhaps we can take this question as well. We've noticed in the video that each truck has its own driver in the story of platooning. that doesn't exactly fit the platooning strategy. Why was it designed as so?
Well, yeah, I can answer this question as well. It's actually it's an interesting one, and because as we know, the platooning means and leader truck drive, and the followers just the following vehicles will just follow the leader and without driver. However, we created this user story and in the real highway, and well, in China, the real highway that is illegal to without driver. Okay, when you use that highway, and you have to have a driver or that. So we have to actually put a driver there, but they are not actually control the car.
All right, for safety reasons as well.
Yeah, for safety reason and for the legal reason.
All right, thank you for this answer. Jing, I don't see any other questions coming in yet. Perhaps I can ask you to share a short thing about the view in the future. What are your aims and what you expect? With your research and the work
yeah,
that you've been doing.
Yeah, we have a lot of things in our mind to do that in the future. We are going to create like the more insightful user stories to test the platooning, and we would like to, well, now there's a lot of limitations so far to test in the closed track. Perhaps we would move this to the change scenarios and to create more scenarios to test RSU and OBU and so on.
Yanjun, would you like to add something before we conclude? Okay. Let me see if there are any other questions coming in.
And I think so. We have left our contact information, and if any questions, please just reach out to us and via the emails after that webinar.
Thank you, Jing. Okay, I see there are no further questions, and I think we got to everyone and their questions so far, and also heard from you your insights and inputs. So I guess we have come to the end of our planned agenda for today. So we will wrap it up here and enjoy an extra few minutes, if that's okay with you. Thank you so much for everyone who joined. Thank you so much to all the speakers for your presentations and your answers today. It's been a pleasure to have you with us today, and also to finish the webinar series on the 5G MOBIX trials trial results and lessons learned. I can see another question that just came in. Perhaps I can take it before concluding. Is that okay with you, everyone?
Oh, yes, please.
All right, let's just take this one and then we can conclude. This is coming from Israel Gonzalez. I have understood that in China, autonomous driving is deployed, how do you consider teleoperation plays a role in the near future traffic regulations? You can also see the question. You can read the question on the chat, Jing, if that will be useful.
Yeah, I think there's a future that is teleoperations will be a future as well, and in this predefined route, but probably not in the public route. And also, the autonomous driving is not deployed in China yet. It's just a step-by-step to deploy. And for example, in one of the big cities, they just launch a new law to, okay, so all these L3 vehicles is able to go to the public road. But I think, and there are like the shuttles already, yeah, I use the teleoperations technique, I think. But I think it has a future. It's a very promising project and the techniques, but still take time to launch in China.
Thank you, Jing. Let's see if we get another question. Please feel free to use the question box before we conclude in case you have any additional question for the speakers. We still have some time left, so we could take one or two more. No, I think we have no further questions from the audience. So now I think it's safe to say that we can wrap it up. As you mentioned, you have included the contact details of all of you in the presentation. The presentations, also the recording of this webinar will be uploaded on the 5G MOBIX website. In the link that you can see now in your screens, you can also find the previous webinars that took place in June and July from the rest of the trial sites. You can find the presentations and the recordings as well in case you want to have a look. This recording will also be uploaded, as I mentioned. And yes, thank you so much to everyone. Thank you again to all the speakers. It's been very interesting, and I hope to see you in next webinar or in the future. Bye, everyone.